page 89. Let's go ahead and get started with these problems. Number 95. Write the area of a circle as a function of the circumference. Write the area of a circle as a function of its circumference C. Now students, what I've taught you to do first of all is start off with your basic formula that you know. So the area of a circle is A equals pi r squared. Now understand what I have here, students, is area in terms of r, or area as a function of r. And that's not what I want. I want area A as a function of C. Okay? So in other words, I want this r to be gone, and I want there to be a C there. Okay? So here is my formula I'm starting off with. Now, somehow I've got to get rid of this r and get a C in there. So somehow over here, I need to have an equation that has a C in it and an r in it. Circumference and radius. Well, students, that really shouldn't be too difficult if you think about it. We know the formula for circumference of a circle is pi d, correct? Sure we do. Well, guys, what is the diameter? Okay, the diameter is 2 times the radius. Remember? So really, instead of having diameter, another formula for circumference is 2 pi r. Let that sink in, guys. Remember, here's the diameter of a circle. Here's the radius of a circle. Okay? The diameter is always 2r. 2 times r, 2 times the radius equals the diameter. So with that in mind, you guys know that in order to find the circumference of a circle, we use pi times diameter, but that's the same thing as 2 pi r. And now I'm getting somewhere. I have an equation here that has a C and it has an r. Now, what do I want to get rid of over here? R. So if I want to get rid of r, then I better get r all by itself and then substitute something in for r. Okay? So if I get r all by itself, that means I divide both sides by 2 pi. And if I divide both sides by 2 pi, I'm left with this right here. Circumference over 2 pi equals r. So think about it, students. If c over 2 pi equals r, what can I put for r right here? C over 2 pi. And then I'm going to have area as a function of c. So here's r. And for r, I put c over 2 pi. Now notice I had to bring down the power of 2. And now we've got to simplify it. But I'm doing really well. Now I have area in terms of circumference. Area in terms of circumference. Okay, let's go ahead and simplify. I'm going to square the c, square the 2, and square the pi. And if you do that, you get c squared 4 pi squared. Now, put this over 1, and then multiply. Your pi is going to cancel with your pi here, leaving you with 1 pi down here. So 1 times c squared, 1 times 4 pi. So you're going to end up with c squared over 4 pi. Okay? C squared over 4 pi. So we did it. We have area in terms of circumference. Not too bad. Now this next problem is pretty difficult. So I hope you're ready to take some really good notes and pay attention, okay? Write the area of an equilateral triangle as a function of s. S is referring to one of its sides, okay? Write the area of an equilateral triangle as a function of the length of its sides, okay? So here we go. First of all, we're going to write down the area of an equilateral triangle, or the formula for the area of an equilateral triangle. So there it is. And also I'm going to write, I went ahead and drew an equilateral triangle. You want to do the same thing so you can see the stuff that I'm going to show you. Well, here's how you find the area of an equilateral triangle, or for that matter, any triangle at all. 1/2 base times height, okay? Now, we want us to have area as a function of s. So I've got to get rid of b, I've got to get rid of h, and I've got to get some s's in here, okay? That's my goal. So, before we get into that, I went ahead and drew a triangle here. Notice it's an equilateral triangle, which means all the sides are the same. So these are not 5, these are s's, okay? So I have an s, and an s for the sides, okay? So we're going to call the sides s, 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 and I'm going to draw the height, and we're going to call that h, okay? So that's pretty simple so far. Now, the first thing I want to show you is this. Are you ready? If I asked you to find the area of this triangle, by 2 or multiply by 1/2. Would I not? Sure I would. If I asked you to find the area of an equilateral triangle that looked like this. If the height was 6 and then all these sides were 5, you would take base times the height and multiply it by 1/2. You would get 15. 6 times 5 is 30. Divided by 2 is 15. Well, it's the same thing here, guys. See this length right here? That's your base. We also call it what? S. So just so you know right off the bat, I can state that S equals B. They're the same thing, guys. This is side S, and this is also the base of the triangle that we would use to find the area. So B equals S. So that's a big help. Now I've gotten rid of this B right here, and now it's an S. So I can make a substitution for B, and I can put an S in for B. So now it looks like this. Here's B, and I put an S. So I'm doing pretty well. I want my area to be in terms of S. So I got rid of this B, I got an S. Now I've got to get rid of this H and somehow make it become an S. So somehow I've got to come up with a formula or an equation over here that has H's and S's. Okay? So I'm thinking how I can do this. It has dawned on me, well look, if I take this half of the triangle here like this side here is still S, this side here is still H, but this side here would be S divided by 2. Now think about it, guys. If I use Pythagorean's theorem, I will have an equation that has only S's and H's. So here we go. Pythagorean's theorem. Okay, so hypotenuse, leg. So leg squared plus leg squared equals hypotenuse squared. Here it is. Here's my one leg squared. Here's my other leg squared. Here's my hypotenuse squared. Once again, this is not a 5. This is an S right here, okay? Alright, well, if we square, well, first of all, we want to get H all by itself. Why do I want to do that? Because once I get H all by itself, H equals something over here. I can pick it up and put it in for H. So I want to get H all by itself, okay? So if I do that correctly, the first thing I'm going to do is bring over the S over 2 squared and make it negative. And then notice I went ahead and squared the S. That's S squared. Went ahead and squared the 2. That's 4. And then brought them over and made them negative. Now, take the square root of both sides, correct? So the square root, actually, no, I'm sorry. We're going to combine these two fractions first, okay? So, think about this. Right now I have a denominator of 4 and a denominator of 1. However, if I multiply the top and the bottom of this fraction by 4, the top gets a 4 and the bottom gets a 4, and that's totally acceptable. And now I have a common denominator. So my common denominator is 4, so I put a 4 right here. 4s squared minus 1s squared is 3s squared. Okay, 3s squared. So now, I'm going to take the square root of both sides. The square root of h squared is h. Now be careful here, guys, look. I'm taking the square root of this whole thing, okay? Now, the square root of 3 I don't know, so I leave it the square root of 3. The square root of s squared is s, so I put an s on the outside, and the square root of 4 is 2, so I put a 2 in the denominator, okay? So let's go over that again. The square root of 3 I don't know, I'll leave it the square root of 3. The square root of s squared is s, the square root of 4 is 2. Now, this whole expression right here equals h, so I can pick that up and I can put it in for h right here. So that's what I do. Here's my 1/2 right here, here's my s right here, then here's my height right here, my h, okay? H equals square root of 3s over 2. Now I'm going to simply simplify this, okay? I put the s over 1. I've got all fractions now. So 1 times s times square root of 3 s. 2 times 1 times 2. So here's what we come up with. Now watch this carefully, guys. We have s right here to the 1 power times s right here to the 1 power gives us s squared. And then 1 times square root of 3 is square root of 3. So square root of 3s squared. The bottom of the fraction is 2 times 1 times 2, which is 4. Okay? That's a pretty challenging problem. That would make a great test question, and hopefully that explanation explanation that I gave you made sense, okay? Hopefully. Okay, now this problem here is the biggest pain that we're going to deal with the entire lesson, okay? It's really a pain, and I'm not going to spend a lot of time on it at all. I'm just telling you right now, if you want me to read to you these 6 rows, I will do that for you very quickly. This is number 99. And actually, I'm not going to spend a lot of time going over this. You can see right here. Now listen to me carefully, and I'll explain this well, okay? Complete 6 rows of the table. They've given us 2 rows already. Now, look at this. Your units are 110. So notice here they put 10. Units are 120. So they put 20. They're subtracting 100. We'll come back to that later. Over here, it's 110 here, so 110 here. 120 here, so 120 here. Okay? Now let's go back up here and read this. What's happening is this. The manufacturer charges $90 per unit for orders of 100 or less, but to encourage larger orders, he reduces the charge by 15 cents per MP3 player for each unit ordered in excess of 100. So he's trying to get people to order more than 100 at a time. Okay? Alright, so here we go. So if we did all these 6 values, all that you're doing, guys, is coming over here and putting in values. Okay? You've got your price P right here, and then your profit P, and all they want you to do is just put in the correct values here and figure it out. See this X right here? What is X? Unit X, 100. So for X you would put 110. Okay? For this P right here, you would put this whole group right here, that whole thing, and then type the whole thing in, and you should get, like for the first one here, you should get 3,135 for this one right here, if you typed all this in correctly. So moving on to the second line, where the X is right here, you would put 120, because that's your X. For your P, you would put this whole group right here, that's your P. Okay? And then type this whole thing into your calculator, and you should get out, according to the book, 3,240. Okay? 3,240. And we could continue that and continue that for the next 4 lines. I'll read the other lines to you. I'm not going to put them up here. We really don't need them. But when X is 130, your value would be, I did not want that, sorry about that. Your value would be 3,315. When X is 140, your profit would be 3,360. When X is 150, your profit would be 3,375. And then when X is 160, your profit will be 3,360. Okay? So there's the filling in the chart. Excuse me for yawning, guys. A little tired tonight. That's the filling in of the charts, okay? Now, plot the points X, P, and decide, is P a function of X? Well, guys, I'm just going to tell you right now, if you were to look this up, in the back of the book, you're going to see a graph that looks something similar to this, depending how you did your tick marks. But the points are going to come up like a parabola. And then stop right here, okay? Now, when you plot these points, does this look like, when you plot the points X, comma, P? Now remember, guys, you said, Mr. Arrow, was X, comma, P? Well, I'm glad you asked. Remember I told you, when you simplified this whole thing right here, you got 3,135. Okay, so what that means is when you have 110 units, X, you'll get this much profit right here, $3,135. Okay, so that's what this is saying. So if you plot these points, go over 110, up 3,135, etc., etc., you'll get this graph right here. Well, does this graph represent a function? Well, guys, you tell me. Think of the vertical line test. Okay, the vertical line test totally passes. There's nowhere you can draw a line, a vertical line, that will pass through the graph in more than one place. It just can't be done, okay? So, is P a function of X? Yes, it is, definitely, okay? Now, students, moving on to letter C. If P is a function of x, which it is, write the function and determine its domain. Now, guys, look, I know how to do this. I've studied all these problems. I've worked all of these problems out before I started this video earlier today, okay? But this is really, there are problems that are difficult because they're good mind stimulating problems. Then there are problems that are difficult because they're poorly written, and I really feel like this one is poorly written. But I'll quickly give you an idea of what they want here, okay? If P is a function of x, write the function and determine its domain, okay? So what they're looking at is this. They want the profit. If P is a function of x, they want the function to be written profit P. So they really give you the whole thing right here. First of all, let me show this to you. If P is a function of x, write the function. What function? Write the P function. Well, here's the profit P function right here. Okay? So, in this case, right here for x, we're going to put 100. So here's x. So we put 100 times, 110 times, now look carefully, x, P comes next, which is this, P, which is this whole thing right here, okay? So we would have 110 times, now, times your P, which is this right here, 90 minus 10 times 0.15, okay? And then next is minus 110 times 60, okay? And of course, where the 110 is, you can put your x there, and then have your function, and then you can put any number in for x that you wanted to. Alright, I'm just not really, to me that was more just like copying what you've already done, okay, in my opinion. So, alright, moving on to number 101, okay. A rectangular package to be sent by the U.S. Postal Service has the maximum allowed combined length and girth. And what is the girth? Now look, guys, it's the perimeter of a cross section. Let me slide this down a little bit. Now look, here's the cross section right here. They call this end the cross section. Got it? So look, they're saying to you girth is the perimeter of the cross section. So all of this. Okay. And so that's what the girth is. Now, you have a rectangular package that's to be sent by the U.S. Postal Service. It has the maximum allowed combined length and girth. So here's the girth right here. Got it? And here's the length right here. So keep that in mind. We're going to use that later. If you add up all four sides here, that's what this says. Girth is the perimeter of the cross section. So if you add up all four sides here, and then plus this length right here, you're going to get 108, alright? So we'll come back to that later. Now, here we go. It says write the volume V as a function of x. So we're going to write volume as a function of x. Got it? Volume as a function of x. Well, first of all, let's write out a good old-fashioned volume formula, okay? So here it is, right there. Capital B stands for area of base. Don't forget that. Capital B stands for area of base. Got it? So the volume of this package is area of the base, right here, times the height. Okay, let's go over that again. Pretend this thing was lifted up and put on its bottom so it was standing tall, okay? This is your base. Right here. Area of the base, area of a square. Okay? How do I know it's a square, by the way? Well, because what is this length here? X. What is this length here? X. So this is X. This is X. We have a 90-degree angles right here. So we know that whatever this length is, X, is the same over here, and so on and so forth. Okay. So what I have is this. I have area of base times the height. That's how you find the volume of this. Now, right now, let's go ahead and simplify this. My area of base is x times x, because once again, please look, students, here's my base right here. How do you find the area of a square? Side times side. So the area of my base is x times x. Look that over and let that sink in, okay? X times x. Now, my goal, don't lose sight of the goal. Your goal is to write volume as a function of x. Right now I have volume as a function of x and h. Okay, right now I have volume as a function of x and h. So where area of my base is, I put x times x. Now let's simplify this a little bit, okay? And now I have x squared times h. X squared times h. So really, students, I want volume as a function of x. All I have to do is get rid of my h, okay? So I wish somewhere I had a formula that had h and x together. Well, guys, you do. You really do. Look, remember, your height right here, your h, is really a y. It is, Mr. Earhart. Well, sure, guys, look. Remember, the volume is area of base times the height. And so here's my base right here. Here's the height right here. That's the same thing as y. Look at it, guys. That's the same thing as y. So really, I can come up with a formula that has h and y. Or excuse me, I want to get rid of the h. H here is the same thing as what? Y. I can come up with a formula that has x and y in it because of this girth and the combined length right here. Remember, if I take all of my sides, look, if I take the length, which is y, plus the girth, and the girth is the perimeter of the cross section. So x plus x, remember, perimeter means the outside of something, okay? So the perimeter would be x plus x plus x plus x. So I have y plus x plus x plus x plus x. So it looks like this. X plus x plus x plus x plus y equals 108. Because, guys, look, it says the length, the combined length and girth is 108. So here's my length y. Here's my girth, the perimeter of the bottom side, x plus x plus x plus x. So there it is. Alright. Now, I'm actually looking pretty good. Let's go ahead and simplify this equation here. 108 equals 4x plus y, correct? Now let's get y by itself. So next I'm going to put 108. Now notice next I put h for y. Remember, h and y are the same thing. Please don't forget that, students. H and y, the height of this, and y are the exact same thing. So for my y right here, I put an h, okay? Now, if I can get rid of this h and get an x in there, then I'll be done. So I'm going to get h all by itself. So bring the 4x over and make it a negative 4x. Now look what I can put for x. I can put 108 minus 4x for h right here. So that's what I'm going to do. So here's my volume. For h right here, I put 108 minus 4x. Now I simplify it, and I get this right here. X squared times 108 is 108x squared. X squared times negative 4x is negative 4x cubed. Okay, so there, I've done it. Students, look what I have. I have volume as a function of x, or volume in terms of x. So I did it. Now, let's go on to part B. What is the domain of the function? Okay, guys, think about this. It's really not that difficult to figure out. I mean, look, you cannot have your x, you cannot have 0 for your x's or your y's. It's impossible. And again, remember, students, the reason x and h or y, remember y h are the same thing in this problem. The reason they can't be 0 is their lengths on a package, okay? So here's what I did. They want to know what the domain is, right? Domain is dealing with x. So here's what I did. I put 0 in for h. Now watch how I do this. So I put 0 in for h. And, now watch. I solve for x. So I bring the 108 over, make it negative 108. Then divide both sides by negative 4, and I get, let's see, 27. Now here's what that tells me, and please listen to me carefully, students. It tells me that if my x is 27, then my h is what? 0. That means if I put 27 in, I get 0 out. Now how can this height right here be 0? Okay, there's no way it can be 0. So I know that x cannot be 27. So by putting 0 in for h and solving for y, listen to me, I found the I found the x value that gives me out 0 for my y value. Okay, so now I've got that breaking point, that boundary. So I know that x cannot be 27 because there's no way my h can be 0. So x cannot be 27. So the question is, do I go up 28 or do I go down to 26? Well, it ends up being, trust me guys, if you put 28 in for x here and simplify, you get out a negative number. If you put right here, if you put 28 in for x right here and took 108 minus 4 times 28, you would get a negative number, and that's possible to get a negative number for h. So if I'm at 27 right here and I went to 28 and that didn't work, then I'm going to go the other direction to 26. And by the way, if you put 26 in here and simplify, you'll get out a positive number. 25, 24, 23, all of those are fine. So your domain is going to have to be x is less than 27. Okay, remember, when we put 27 in for x, we got out 0. Remember? So what that means is if my x value, my girth around the end, my x, if my x value is 27, then my y value or my h value would have to be 0, and that's impossible. So I know that my x values have to be less than 27. They have to be, okay? Now, let's take the challenge real quick with the graphing calculator. Let me grab mine real quick, and let's graph this function. So let me go back forward here. Alright, here's the function. We're going to graph this function right here, okay? Let me clear my calculator. And here we go. 108 x squared minus 4x to the third power. Alright, let's graph that. And it might not show up very well. Yeah, I'll have to change my window, it looks like. Okay, I'm going to change my window to my x-axis. I'm going to make it maybe like a -2 and a +2 to stretch this graph out, because right now it's looking like this on your screen. It's all wrapped around the y-axis. I'm going to try to spread it out a little bit. Alright, and let's see what we get when we do that. Okay, a little better. Okay, students, I paused the video and got a little better idea of what the window should be, and this makes total sense. Remember, guys, your domain, I'm not sure why I said +2, -2, and tried to stretch it out. Look, remember your domain is less than 27, and I know that x could not be 0. That's impossible. So what I did is I set my window from 0 to 30 on my x values, okay? So my x minimum on my window is 0, and my x max is 30. Now, if you'll look at a table of values, whatever you need to look at, guys, let me look at mine real quick here. If you'll look at a table of values, on your graphing calculator, start scrolling. I'm going to just literally start scrolling. Start at 0 on your x and start scrolling. These numbers are getting huge fast, okay? And so it's looking like I'm scrolling down about 12,000 is about as high as the y values go for what we're looking at. So I set my y windows from 0 to, excuse me for yawning, from 0 to 12,000, okay? And I'm getting a really nice graph when I do that. It looks just like this. It looks really good. It's, here's the coordinate plane, and it's starting just about right here, and it's going up, and then coming down, okay? There we go. And so now, there's a graph of it. Now, what dimensions will maximize the volume of the package? In other words, what do you want x and y to be to give you the largest volume, but yet still to meet these needs? So guys, think about it. Your graph gives it away. You want the maximum volume. Look at your formula here, guys. You're putting values in for what? X. And getting out values for what? V, the volume. Okay, so if we want to find the maximum volume, it's going to be this high point right here, and we've learned how to do that with our calculators, guys. So let's use our calculators. Remember, we go to second calculations. Okay, so second trace or second calculation, and the third, let's see, the fourth option down says maximum. Okay, so scroll down to that and hit enter. It's going to say left bound, so make sure your cursor's over here somewhere. Hit OK. Then make sure that you scroll past the high point. So I would move your cursor all the way to about right here, and then hit enter. And then it says guess on your screen, Guess. Hit enter again, and it gives you the ordered pairs. Right there in front of you, look at that. It says 18, comma, 11,664. Now let's interpret that answer. Okay, let's interpret what this means. It means if your x value is 18, then your volume is going to be 11,664. Then it starts going back, and then it starts going back down. So this is your maximum point. That's your highest point. So when it says what dimensions will maximize the volume, well, hold on, guys. We're not out of the woods yet. We know what dimensions do we want? That means we need our x's and our y's. Well, look, we know what x is. X is 18. Okay. So let's go back here to where I had. Well, I don't know where I've put that. Look back over here. Okay, I know that 18 is going to be my x value. Alright, so let's come back up here. Remember, guys, I said this over and over during this problem. H is the same thing as y. H is the same thing as y in this problem. So, to get the proper dimensions, I know I want x to be 18. Because when x is 18, I get out this marvelous volume. So I'm going to come up here to my x, and I'm going to put 18. So 108 minus 4 times 18, okay, would equal y. So now I know what my y is. So 108 minus 72, I believe it was. Okay, and of course, 108 minus 72 is 36. Alright, 36. So there's your dimensions, guys. We did it. X would have to be 18, and y would have to be 36. Alright, so there's the dimensions of the package right here. That gives you the greatest volume on the inside. Okay, alright, let's go ahead and continue on to the next one, number 103. Okay, this one's pretty simple here. The inventor of a new handheld video game estimates that the variable cost for producing the game is 95 cents per unit, and the fixed cost is 6,000. The inventor sells them for $14.99 each. Let X be the number of games sold. Now listen to what part A says. This is a really easy problem. The total cost for a business, the total cost, not the profit, the total cost for the business is the sum of the variable cost and the fixed cost, which we knew that already. I mean, look, if you want to know the total cost, you add up all the cost. So write the total cost as a function of the number of games sold. Okay, so here we go. Really, it's pretty simple. Here it is. We know it's 95 cents per unit, so 0.95x, and then plus, there's already a fixed cost cost of 6,000, okay, right here. So there it is, that easy, guys. 95 cents per unit, so 95 cents times X, and then plus 6,000 for a fixed cost. Alright, now it says write the average cost, C, write the average cost per unit as a function of X, okay? Now look, we already have here a cost function based on X, which is your number of units, okay? Now think about it, guys. They want us to write the average cost per unit. So this, now come on, think about this. This is your total cost right here. C equals all of this. Well, how would you find out the average cost per unit? Well, look, guys, if you made 500, then you would divide the whole thing when you were done by 500 to find the average, because it says find the average cost per unit. So what I'm going to do is I'm simply going to take this is my total cost right here, 0.95 times X plus 6,000. I'm going to take my total cost and I'm going to divide that by X, okay? Because that's how I'm trying to find out the amount of cost per unit, and X is my amount of units. So I'm taking my total cost and dividing it by how many units I actually sent out, and that will give me an average cost per unit as a function of X. Now the back of the book simplified this a little more, but I have no problem leaving this for your answer. Man, just one more time quickly, guys, I'll go over this. The cost for this company is right here. There's the cost. Well, how do you find the cost per unit? You divide it right here by how many units you made, and that will give you the average cost per unit, okay? Hope that makes sense. Alright, moving on to number 105. Alright, the force F in tons of water against the face of a dam is estimated by this function right here, where Y is the depth of the water in feet. Now, complete the table. What can you conclude from the table? So they want you to put a 5 in for Y, then a 10 in for Y, 30 in for Y, 40 in for Y, and really, to be honest with you guys, I mean, if I were you, I would just simply put a 5 in for Y right here. I'd put a 5 right here, and with my calculator, my arrow button, I would take 5 to the 5/2 power, enter, times the square root of 10, enter, times 149.76, enter, okay? And if you do all of that correctly, I'm going to give you these values really quick. Well, this one here, I'm not going to write it all out. It'll be around 26 million. Number 10 would be around 149 million. Uh, 20 would be 847 million. 30 would be, let's see. No, I'm wrong, guys. I'm sorry. I have this book so far away from my eyes. 26,000. There we go. 26,000. The next one would be 100. I'm rounding these, guys. I'm totally rounding these. 149,000. 20 would be 847,000. 30 would be 2 million. 2.3 million, we'll say. 2.3. And then 40 would be 4 million, about 4.7 million. Okay. Now, this is a pretty obvious question, okay? What can you conclude from the table? Well, as the depth increases, so does the force, because the force has gotten higher and higher as the depth has gotten higher and higher, okay? So that's a pretty simple question to answer. Now, use the table to approximate the depth at which the force against the dam is 1,000,000 tons. How could you find a better estimate? Now, guys, listen. I mean, they want us to use the table to estimate when we're going to get to 1,000,000, okay? So we have 847,000. Then we jump all the way to 2.3 million. So I know it's not going to be in the middle somewhere, okay? It's not going to be in the middle. I'm assuming it's going to be closer to the 20s probably. Maybe like 20, 22, or 23. I think the back of the book actually has 21, but we're just estimating, okay? Now, how could you find a better estimate? Well, guys, don't use gaps from 5 to 10 to 20 to 30 to 40. You could actually choose values between 20 and 30, and make them smaller, like 21, 22, 23, 24, and 25, and that would help you find a more specific answer as to how much force is needed, or how much depth is needed when you have a force of 1 million tons. Okay? Alright, let's go ahead and continue on to number 115. Okay? Now, they're giving us two functions here. They're telling you the card, the cost of using a telephone calling card is $1.05 for the first minute and 38 cents for each additional minute. Now they're asking you which one of these, and by the way, we're not going to graph this, so don't worry about graphing it, okay? But they're asking you which one of these two equations, and notice we have greater integer equations here. We have the line here, and then one coming down, okay? So don't forget that. But anyways, we're going to decide which one of these two equations maps or models the situation up here the best. Alright, so here we go. Now think, students, if all they're asking us is which which equation models the situation the best, do what I did. All you have to do is just very quickly with your brain. I did this. I said, okay, I'm going to talk for 3.5 minutes. So forget these models for a second. I'm just going to use good old common horse sense. I'm going to talk for 3.5 minutes. Now if I talk for 3.5 minutes, that gets rounded up to how many minutes? 4. Now the first minute is how much? $1.05. So now I'm down to 3 minutes. Each one of those minutes, the first minute was $1.05. These three remaining minutes cost 38 cents each, which would be what? 24 carry to $1.14. So when you add it all up, you get $2.19. Okay, $1.05 for the first minute and $1.14 for the next 3 minutes. So when I talked for 3.5 minutes, it cost me how much? $2.19. Okay. When I talked for 3.5 minutes. Now, let's put 3.5 in each one of these models and see if we get out $2.19. And you're going to see this one doesn't work and this one does, but let me show you, okay? Alright, here we go. I'm going to slide this up a little bit, get some more room. Alright, let's see which one of these two equations will match up to $2.19. So I'm going to put 3.5 minutes in. I'm going to put 3.5 right here. 3.5 right here for t, okay? Now watch carefully what happens. 3.5 minus 1 gives you 2.5. So now you have $1.05 plus 0.38. Now be careful here. It's greatest integer. So 3.5 minus 1 is 2.5. Okay? So 3.5 minus 2.5. I now have 2.5 inside my greatest integer notations. Now remember, students, just like absolute value means make the number positive, greatest integer notation means that you want to go to the nearest integer that is less than the greatest integer below this. So think of a number line. Here's the number line. Here's 1, 2, 3. Here's 2.5 right here. Going to the left, what's the first integer I come to? 2. So the greatest integer of 2.5 is really just going to be 2. Now that's how you'll do those every time, okay? You're always going to go to the left, okay? The first integer you come to, going from the left, okay? So now if you take this, trust me, you're not going to get $2.19. cents. You're going to get $1.05 plus, let's see, 76 cents. Alright, so $1.05 plus 76 gives you $1.81. So this top model here did not work. Okay, let's try the bottom model just to make sure that it works. Okay, so here we go. I'm going to put 3.5 in right here. So 3.5 minus 1 is 2.5. Okay, there's a negative sign right here, so negative 2.5. So I have 1.05 minus 0.38, and then greatest integer. Let's see, I would have, like I said, we're putting 3.5 in for t, so 3.5 minus 1 is 2.5, but there's a negative sign there, so negative 2.5. Now think of a number line, okay? Here's negative 2, here's negative 3, here's negative 2.5 right here. Remember, you always go to the left, to the greatest integer, alright? So, instead of having negative 2.5, I'm going to go to the left, to the first integer I come to, which is negative 3. This is going to work perfectly, guys. Look, I have negative 0.38 times negative 3. Okay, now a negative times a negative is a positive, so now I have $1.05, and if you take 38 times 3, you're going to get a dollar, what we just have, I forget, $1.14. So 38 times 3 is $1.14. Add those two together, and you will get $2.19, which I know we're supposed to get. So this is the correct model, okay? I'm not going to worry about graphing it. Alright, moving on to number 17. Now, the directions say to write the height of that rectangle as a function of x. The height as a function of x, okay? So here we go. Think about it. First of all, students, if I can find the total height all the way up and down, okay? And then, students, find the height from here down. I can subtract the 2. For example, look, if I knew this whole entire height from here to here was 10, and I knew the height from here to here was 6, I could take 10 minus 6, and what's left over is 4, and I'll have that as the height of the rectangle would be 4. Okay, so here's what we have to do. First of all, think about it, guys. I already know the height from here to here. You do? Yeah, definitely. Look, we're over 1 up 2, over 3 up 2. So the height of this thing is right at 2. Okay? So I know the green line right here is 2. Now, how can I find the height from here? Now watch carefully, students. From here all the way up to here on that dotted line. Now, are you serious? This is not too bad at all. This is pretty simple. Look, guys, think about it. How far over am I on the x-axis? I'm over to x. I don't know the number, but it's somewhere right here. Now think about it, guys. Look, if I were to put 3 in for x, just listen for a second. If I were to put 3 in for x right here, if I were to put 3 in for x, it would give me out 2. Okay? It would. It would tell me where I'm at on the graph. So if I put x in for x, it should give me the entire distance of this entire line from here all the way up. Because if I put x in for x, it's going to give me out, theoretically, this ordered pair right here. Just like if I put 1 in for x, I get out a 2. Okay? So, how far over am I on the x-axis? X. So I'm going to put x in for x. Well, guys, think about it. If you put x in for x, nothing's going to change. You're still going to have negative x squared plus 4x plus 1, okay? So this expression right here is the entire distance from here all the way up to the top, alright? And then from here to here is just 2. So you subtract that out like this. Okay, and by the way, this positive 1 right here should be a negative 1, alright? So now I'm left with negative x squared plus 4x minus 3, okay? Now that would be the length of same thing, only now we have two linear equations, okay? So please think this through, students. Okay, how can I find the distance from here up to here? Well, let me show you how to do it, okay? Here's my linear equation right here. See it? There's my linear graph right there. And the equation for that linear graph is y equals 2x. So guys, come on, think about it. If I want to find any point on this line, all I have to do is put a number in for x that corresponds to that point, and I'll get out a y. So the only problem with this problem is I'm going to have to use x right here to get my ordered pair right here. So basically I'm putting x in for x right here, okay? So if I put x in for x, y equals 2, parentheses, put an x in for x, you still get out the same thing, 2x. So what is the height from here to here is 2x. Alright, now what's the entire height, students, from here all the way down, the entire height? Well, it's not that hard to figure. Put x in to this equation here, and you'll get out this ordered pair right here. It'll give you the height from here all the way up. So I'm going to put x in to this function right here, and that's pretty easy. I mean, I'm putting an x in for x, and I'm putting x in for x squared. So by the time I'm done simplifying that, guys, I'm going to get the exact same thing. I'm going to get y equals 4x minus x squared. Now, this represents the whole entire height all the way up. So I'm going to take this expression here, 4x minus x squared, and then subtract 2x, okay? Minus 2x. 4x minus 2x will give you 2x minus x squared, okay? 2x minus x squared, alright? So the entire length of the line minus the shorter one, okay? Alright, moving on to number 121. Now we're dealing with width. So now we're going to write the width in terms of y, and that's really not too difficult, students. Look, all I want to know is the distance from here to here, okay? The distance from here to here. In other words, this ordered pair right here. Okay, students, I'm back. Sorry, I had to take a little interruption there. Okay, now look, students, think about this. Now we're dealing with how far over it is. Guys, listen, it's backwards. X, comma, y. If I put in an x value, I get out a y value. However, if I put in a y value, I'll get out an x value. Okay? And of course the x value is, look guys, the x value is how far over I am. So I'm going to put a y value in to this equation. I'm going to put in how far up I am. And here's how far up I am. They're telling me I'm y units up. So I'm going to put y in for y. It's so funny. Here's y. I'm going to put y for y. And you get the exact same thing, guys. Okay, so how long is this rectangle in terms of y? This right here. How do I know that? Because I put my y value in, which is y, and I got out this here for my x value. So that's how wide the rectangle is. These are decently tough. I-123. Okay, it's really going to be pretty much the same thing, guys. So here we go. Okay, first of all, I want to know how wide this rectangle is. Now please watch in terms of y. Now watch this. I already know the distance from here all the way over. And you're probably like, really? Yeah, it's 4, 2. It says I'm over 4 and up 2, okay? So I know the whole distance of this blue line is 4, okay? Now please don't forget that. We'll come back to that later. Now, next, think about it. If I can find the distance from here to here, and the whole distance all the way across is 4, I can take minus this number here, and that'll give me the length of the rectangle. Go over that again. If I can take the entire length of this line, which is 4, and subtract this out, then what I'm left over with has to be the length of this rectangle here, okay, in terms of y. So here we go. I'm going to see if I can't find the distance from here to here. In other words, I want to find the length, the ordered pair. Well, look, this is my y value, so I know I'm this far up. So if I put my y value in, then I'll get out my x value, which will be how far over I am. Let me say that again. If I put my y value in, that's how far up I am. I will get out my x value, which is how far over I am. So I'm going to put y in real quick for y. X equals y squared. So there you go. X equals y squared. Okay? So now look, I know the entire length. I know from here to here we're calling that y squared. And I know the entire length all the way across is 4. So to find the length of that rectangle, I would take the entire length, which is 4, and subtract this length from here to here, which is y squared. And that would be the correct answer. Okay, students, not easy stuff, I know that, but stuff that you really need to work on and make sure you understand, okay? I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call